Hello everyone. I hope you people are enjoying the DSA 30 days challenge. Let's see the DSA challenge number 11. Right? Let's see the DSA challenge number 11. So this is the problem which I explained in the last class. One array is there consisting of zeros, ones and twos. The task is to sort the array. That is, put all zeros first, then second, then third. Right? Like that. Zeros, ones, twos you have to keep. Suppose if I take one example like, right, array A contain these elements. Let's take some 10 people. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me take the some values 2, 0, 1, 0, 2, 1, 0, 0, 1, 2, like that some elements are. So if you sort this array, it should look like this. If you sort this array, it should look like this. So if you sort this array, how many zeros are there? 4 zeros. How many ones are there? 3 ones. How many twos are there? 2. Right, like this. So sorting, simply sorting. This is the answer. So what is the answer for this? You may say that, sir, how to solve this problem? I think just sort. Apply merge sort and sort. Or apply heap sort and sort. So merge sort or heap sort will take n log n time. Every case. Right? If you want, you can go for heap sort. Right? N log n time. Right? Every case. Merge sort. But merge sort is having the one problem, that is it may take more space. Merge sort is not in place, it is out place. So if you want to merge, if you don't want to merge sort, go to the heap sort, which will take which will take less space. Right? So time complexity order of n log n, depending upon which sorting algorithm you will apply. Merge sort will take time complexity n log n. Merge sort, depending upon the sorting technique, space may increase, space may decrease, something like this. You can go for merge sort, you can go for heap sort. If space is a problem, go to the heap sort. Go to the quick sort. Right? Go to the quick sort, but quick sort worst case is n square. Right? That is the reason time complexity, by thinking I written the merge sort. It's okay. Simply time complexity n log n. Now let's come to, because there are some better approaches are there. Here you no need to bother. One answer is just simply sort, apply merge sort. Right? One more algorithm. I think very interesting. This algorithm everyone knows also. Let me write. So I'm taking the same example again. Same example once again I'm taking. Right? Don't worry that much about the previous one. Simply sort. But if at all so many elements are there, so many different types of elements are there, you can sort. But special people are there, 0, 1, 2. Then why you follow normal sorting algorithm? There is a one better approach. You can see this. There is a one better approach I'm going to explain. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me write 2, 1, 0, 2, 1, 0, 0, 1, 2, 0. Some numbers. Right? What the one way is, listen, one way is very simple. One way is see everyone now. One way is take 3 variables. Count zeros, count ones, count two. Take 3 variables first. Initially all are zeros. Now what you do is in the A array, 2 comes, increment the 2's. 1 comes, increment 1's. Zeros comes increment zeros. Twos comes increment. Ones come increment. Zeros comes increment. Zeros come increment. Ones come increment. Twos come increment. Zeros come increment. So like that. Totally 4 plus 3, 7, 7 plus 3, totally 10 people. So now after incrementing, I think one scan is over. One scan is over. You got to know how many zeros, how many ones, how many twos. So take one for loop 4 times, take one for loop, see 0 times, means 4 times, store zeros. Let me use another color. Take one for loop, C0 is 4 times only that loop. Store all zeros first place. Next one, take one more loop, C1 times only, 3 times, store ones. Take one more loop, right, C2 times only, store twos, over. So these all three combinedly will take one more n. Totally 2 scans you done, 2n time. So order of n. Every case. Interesting thing is you are not taking one more array. Within the array you are managing. So order of one space. Order of one space. Because you are not taking one more array. Same array you can adjust. Same array you can adjust. So I think same thing I written in the form of a program also you can check. It is a main program. It's okay. From main program, sort function is called. Go to the main program. In the main, from the main program, sort function call. See the sort function. Nothing. I have not done anything. I just took one for loop. Whenever it is going on, I am counting how many zeros. I am counting how many ones. I am counting how many twos. So as for our problem, this came 4 times. This came 3 times. This came 3 times. Now I took right 3 for loop. First for loop is C0 times. Second for loop is C1 times. Next for loop is C2 times. Next for loop is C2 times. C0 times, C1 times, C2 times. I hope everything is fine. So this will take n time. This will take n time. Overall 2n. So overall order of n. This is the time complexity. Space complexity order of 1. If you want, you can check. Everywhere I am using array A only. Everywhere I am using array only. I am not taking one more array. I am not taken one more array. Everywhere is array A won't be there. So order of one space. This is the one of the nice algorithm comparing previous one. Don't think much about previous one. There is one more algorithm is there. I think here you done 2 scans, 2n, right? But one scan also you can do it. One scan also. One scan also, just managing the variables. So how one more, right? How it is, let me check. Careful. This is array. Within one scan you can do it. I will try. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let us assume that elements are these. These are the elements. These are the elements assumed. Some elements like this. So what you will do is, let's take 3 variables first. So let us assume that, right, bigger one, right? Bigger index is assume that high. Lower index assume that L. In the same place keep the M also. Lower place keep M also initially. Right? So 3 pointers, 3 variable or 3 pointers you take. Or 3 variables. 3 pointers or 3 variables. Where low and mid initially 0th index. Right? Initially. So high is there at the last index 9. Right? So remember everyone. Low purpose zeros, mid purpose ones, high purpose, right? I think 2's purpose high. This is the basic purpose why I take three variables. Zero's purpose low, one's purpose mid, two's purpose high, right? That is the basic purpose. Now you can see one time. What within one scan I have to do. So whenever if it is zero, right? So a of right, so a of zero, this one. Whenever value is zero, see this one, value is zero, then what you do is spare if at all value zero, right? This one, value zero, spare, right? Low and mid, low and mid. It's a low, it is a mid. If you want, you can keep low and mid. Whenever it is zero, swap a of low, a of mid means swap itself. Swap itself, right? And not only that, low also increment, mid also increment. Whenever zero comes, swap a of low, a of mid. Right? Afterwards, increment also. Right? What is the reason? You will see that. Next one, in the similar way, again check zero. Same, a of low, a of mid, swapped. It will be swapped himself. Then m also increment, l also increment. Next, if it is one, remember one, case one. If it is one, then what you do is only mid only will increment. If it is one again, mid only will increment. That's what I said to you. Low meant for zeros, right? Mid meant for ones. Low meant for zeros, mid meant for ones. H meant for twos. Careful. Right? Next one. Whenever one coming, increment. Now see, two coming. Whenever two coming, every one or two belongs to high. Then what you do is swap A of mid, A of high. Whenever two comes, mid, swap these two. Two here, zero here. But remember, after swapping, high only will decrement. High will become here. Again, same story you see. Again, same story because mid is not incremented. Again, check. Is it zero? If it is zero, you know very well. Mid and low should be swapped. Then afterwards, low also increment, mid also increment. Whenever zero comes, very simple. Whenever zero comes, low and mid swap. Low and mid swap. Then low will increment, mid also will increment. If one comes, only mid increment. If two come, mid and high both will be swapped. Afterwards, high will be decremented. Afterwards, high will be decremented. Afterwards, again one. So mid will increment. So remember, at any point of time, comparing mid and high will be greater. High will mid and high, mid less than high, right? Until this condition happened, continue. So this is the same story. See, mid less than or equal to. If equal also, you can stop. Whenever both are equal, you can stop. So what I mean to say is, if at all zero comes to do this, if at all ones comes do this, if twos comes do this. Whenever zeros comes, low and mid both will right swapped and incremented. First to swap, then increment. Whenever twos will come, mid and high will be swapped, high only will decrement. Whenever one will happen, only mid will increment. Right? If you do that within one scan, you can manage it. Within one scan. So finally, one scan, so order of n time. So time complexity every case. What about space? Order of one. It is a better one. Previous one, this one same asymptotically, but mathematically little bit difference. It is a space. Space complexity this much. I hope you got it. Simply little variation to the previous one. For this one, it is a little variation. It is a little variation. Right? Please careful. Within one scan, you can manage it. I hope you got it. Yeah, if anyone find out any one more interesting one, please let me know. First approach is sorting. Second one is two scans. Third one is one scan. One scan you can manage it. Right? For second one and third one both are similar, asymptotically, but mathematically little bit different. Little bit. Yeah, fine, perfect. Any doubt there in the comment section you can type. We will see those, and if any improvement is there, we will let you know.